In this video, we are going to look at yet another sorting algorithm, namely Quicksort. Now, in this video, mainly I'm going to talk about the main idea and then do a couple of examples. But then in the next video, we go into more detail and we also look at how Quicksort can be implemented in C++. So similar to merge sort, Quicksort is also based on the idea of divide and conquer. So Quicksort is also based on divide and conquer, similar to merge sort. But the way that you divide the original input into smaller subarrays is completely different. So here's how you do that. Let me start with a picture and then I will write it down. So let's say this is your original array that you're about to sort using Quicksort. So what you do is you pick some element in the array that is called the pivot. Now, how we choose the pivot, there are different ways, and I will talk about that, but pick one of the elements of the array as the pivot. And then what we do is we partition, which is what divide calls in the context of Quicksort. So we partition this into two subarrays, where in the left subarray, we put all the elements in the original input array that are less than x. So everything less than x, or pivot, goes to the left, and everything greater than the pivot x goes to the right. So you see that immediately partitioning or the divide step in Quicksort is different from merge sort. In merge sort, we didn't care about the elements in the array. We just divided that into two halves right in the middle. But here we look at all the elements and we put everything that is less than x in the left and everything that is greater than x to the right, and obviously x belongs in the middle, right? Now, note that the left and right subarrays are not necessarily sorted. We just picked everything that is, let's say the pivot was 20, so everything in the array that is less than 20 goes to the left, everything that is greater than 20 goes to the right. Then, so that's the divide or partitioning. Then what we do is we apply Quicksort, QS for Quicksort, to the subarrays. Okay, so I get same elements but now sorted, x, and then same element as here but now sorted. So less than x and sorted, right? Here we have everything greater than x and now they are sorted. Okay, so divide is different from merge sort. Instead of dividing exactly in the middle, we pick an element called the pivot and then we partition it as everything less than x goes to the left, everything greater than x goes to the right, x is obviously in the middle, and then the conquer part, by making two recursive calls to Quicksort, we sort the left and right subarrays. And here's the nice thing about Quicksort is that, remember in merge sort, after divide and conquer, then we have to combine them with the merge function, and the merge function was the majority of the work. If you remember, it was like 20 or something lines of code to implement the merge method. Right here, you don't need to do anything. This is the answer. So there is no merging involved. You just put them together side by side, and there you go. You have the final answer. The reason is, imagine that x is like 20. So on the left side, we have all the numbers that have less than 20, and they are already sorted. So like 2, 7, 15, 18, 19. And then comes 20, which is the pivot. So we are still sorted. And then on the right side, we have elements that are greater than x, greater than 20, and they are also sorted. We get 25, 31, 100, and so on. So there is no reason, or there is no need, I should say, to do anything extra, because we did more work in the partitioning. Here, we are using that, and the merge part or the combination part is simpler. right? So in comparison to merge sort, in a merge sort, the divide step is kind of trivial. You just divide it into half, right in the middle, and then you make recursive calls. But then the merge part, the combining part, takes longer. But for quicksort, the divide part, partitioning, requires some work because you have to go through the array and find out which one of the elements are less than the pivot. You put them in the left, and whichever is greater, you put that to the right. And that requires some work, so it's non-trivial. But then the price, and you pay the price here, and then at the end, the merge or combine part is very easy. Actually, there isn't anything to do there. Okay, so that's quicksort with a picture. Now, if you want to write it down, here are the steps. Step 1, pick an element from the input, which we call the pivot. Okay, now how this is done, I will tell you in a moment. Step 2, partition or divide the input array into two subarrays. Two subarrays. One that contains all elements of the input array that are less than the pivot, and then another that contains all the elements of the input array that are greater than the pivot. So that's the divide pivot. That's the divide step. Now, one thing that I want to mention here is that if your pivot, let's say your pivot is X, and there are elements that are equal to the pivot, equal to X, then you can put them either in the first or the second subarray, and it doesn't make a difference. Now, recursively, sort both subarrays. So that's the conquer part. So divide, conquer, and then the combination part is trivial. So the combine step is trivial. Okay, then let me write here. So there you have it. That's the idea. Now, before getting into the actual implementation and the details, let me tell you how we choose the pivot here, because the first step is choosing a pivot. And as it turns out, it's very important how you choose the pivot. Now, some options for choosing the pivot are as follows. So can be, the pivot can be one option is always choose the first element of the array as the pivot. Another option is the last element of the array. Another option is you can choose your pivot randomly from the array, from the input array. Okay, and the more advanced version is choosing the median element of the array as the pivot. Now, the median in statistics, if you have a list of numbers, the median is the number that roughly 50% of the numbers are less than that and 50% are greater than that. But then computing the median takes a little bit of time as well, so there's a trade-off there. So usually, choosing it randomly, it can be done fast, and on average, it works very well. So that's how one of these options you can pick your pivot, and then the rest is, as we said, everything that is less than that your pivot goes to the left, everything that is greater than goes to the right, the pivot is in the middle, and then you make two recursive calls, sort, sort, and then you're done. So that's Quicksort. Now, before moving on and seeing more detail, I want to do an example here so that we are sure that we understand how these steps work. And then in the next video, I'll show you the implementation. And to be able to do that, we need to look at the same ideas, but with a little bit more detail. I'm hiding some of the details here because if this is your first time seeing this, I don't want to make it too complicated for the first time. Okay, so let's say your input array has 10, 7, 11, 4, 21, 16, 9, and 8. Okay, now for the first step, I choose my pivot to be the first element. So pivot is 10. Okay, now we have to partition this, right? So the elements that are less than 10, we have 7, we have 4, and we have 9, and 8. So this is the subarray that contains everything that is less than 10. Then 10 itself goes in the middle. I'm using circles for the pivot because there will be pivots in the recursive calls as well. And then on the right side, we will have every element that is greater than the pivot. So 11, 21, and 16. Okay, so that's the first step. Now, if you remember, after choosing the pivot and partitioning, I have to make recursive calls on Quicksort on this array and this array. So it means that, again, I have to choose a pivot here. So pivot in this example is always the first element, 7. So I have to divide or partition this array into an array that contains all the numbers that are less than 7, so 4. And then comes the pivot, which is 7. And then everything that is greater than 7, which is 9 and 8. Note that we are not sorting these, right? I didn't say 8 and 9. I'm just copying down all the numbers that are greater than the pivot on the right side. Then we have 10. And here, again, I have to make a recursive call. The first element is the pivot, so the pivot is 11. So there isn't anything less than 11, so the left subarray is empty. Then I have the pivot, which is 11, and then everything that is greater than 11 goes to the right, which is 21 and 16. Okay, now, again, since this is a recursive call, remember that there must be a base case. The base case is when the size of the array is either 1 or 0. Okay, so here, when I make recursive call on this array, because the size is 1, it just becomes 4. The pivot stays where it is. And for this one, the size is 2, so I have to choose a pivot. So the pivot is the first element, 9. And I have to divide that into an array that contains everything that is less than the pivot, which is 8, the pivot itself, which is 9, and then everything that is greater than the pivot, which there isn't any, right? Then we have 10, then we have 11, and then here for these guys, again, the size is 2, so the pivot is the first element, 21, and then everything that is less than the pivot is 16 is less than the pivot. Then we have pivot, 21, and then the empty subarray for everything that is greater than the pivot, which there isn't. Okay, now when we make recursive calls, what is left is only arrays of size 0 or 1, and the recursive call returns it, and that's the base case. When the size is 0 or 1, it just returns the array as is, and we are done. So the recursive call, return, and then we are the execution terminates, And you can see that we have 4, 7, 8, 9, 10, 11, 16, and 21, and the array is already stored. Okay, so that's a very brief explanation of how Quicksort works. Now, the detail that I did not talk about here is that how the partitioning works. Here, we did it kind of like by looking at the array, but in the next video, I'm going to show you how partitioning is done algorithmically. What are the steps involved in partitioning? And we will see that most of the work is done in partition. When we implement this, the majority of the code will be in the function that takes care of partitioning. The quicksort itself will be a few lines of code. So in that sense, it's kind of similar to merge sort, where most of the work was done in the merge helper function. Okay, and we will do that in place, which means that here I'm drawing this as if I'm creating new arrays and copying elements down, but we don't want to do that because it's wasteful in terms of the memory. So if possible, we would like to do that in place, which means that in the same